comes before, so it's more important. We go with that rule. And here, hydrogen is written first as well, instead of being written second here. So a lot of things saying hydrogen's plus 1. 2 times 1 is 2 plus, well, if this is negative 2 like it normally would be, then we would have 2 plus negative 4, which would not equal 0. So this can't be negative 2. It has to be negative 1 in this case. So oxygen here is negative 1. The next rule, the most electronegative element in the group takes its lowest oxidation number, which is its group number minus 8. So for example, here we don't really know out of these two. We don't have a rule that says that. We do know that they have to add up to equal 0. So out of P and Cl, which is the most electronegative? Well, it is Cl. Cl has 3 and P has 2.1. So we take its 8 minus its group number. And if you know your charges, that's just the same as what we normally would have written up there for their charges. So when we look at that, chlorine is going to be negative 1. Well, that means that even though phosphorus, we're used to it having a negative 3, this isn't an ionic compound. So instead of taking electrons or losing electrons, they're sharing them. So the amount of the electronegativity of chlorine says it's going to not fully want to share those equally. So it's going to take them and pull those in closer. We know that as a polar bond, right? So what that means is the phosphorus here is going to lose those electrons in a little bit of a sense. Well, how much is it going to lose them? Well, if this has to equal 0 when we add it up, x minus 3 has to equal 0, well then x must be plus 3. That's it. That's oxidation numbers. So I'll go through a few of these real quick. So we have example 1, KMnO4. So K we know is plus 1 because it's in group 1A. Oxygen we assume is negative 2. So that means that 1 plus x minus 8 has to equal 0. Well, what is x? X must be 7. Boom. Cr2O7, negative 2. So we don't know chromium. We do know oxygen is negative 2, because that's what it usually is. And there's nothing, there's no other rule here that would allow it to be anything else, since we don't know chromium. So negative 2, that gives us negative 14. And then we have 2 here, so that's 2x minus 14 has to equal negative 2. Well, your algebra skills hopefully will teach you we can add 2 to both sides, so that gives us 2x equals 2x minus 12 equals 0. And then we can add 12 to both sides, so that gives us 2x equals 12. Well, we divide by 2 to get x equals 6. S8. Well, if we take a look, S8, its elemental form, sulfur. So it's 0, because 8 times 0 equals 0. And since there's no charge out there, doesn't leave us with much else. Cr3 plus. Well, 1 times x has to equal 3 plus. So Cr here is 3 plus. H2S. If we take a look, we know H is usually plus 1. So that means 2 plus x has to equal 0. So that gives us sulfur as negative 2. Boom. So I will put the answers up for exercise 1 and exercise 2 and exercise 3. And then what I would like for you to do is to do some of these as practice. But what we're going to turn in is this sheet right here, a picture of page 9. So if we take a look up here, you are going to assign the oxidation numbers. Down here, you're going to write out what's oxidized and what's reduced. So let's go through that again. Here we have Na, so that is 0. Here we have Cl, that is 0, since they're in their elemental forms. Over here, it's in a compound, so whatever they add up to equal has to be 0. Well, sodium is in group 1A, so the rule for that says it has a +1 charge. So it has a +1 oxidation number. Cl then must have a -1. So that means that sodium has gone up. So that means that sodium has been oxidized. Cl has been gone down, and if something goes down, we say it is reduced. Now here's the last thing that this asks for. It asks for this oxidizing and reducing agent. Well, basically, if something is oxidized, that means the compound that it's in this case, it's not a compound, it's just sodium. That means that it is the reducing agent. And if something is reduced, that means it did the oxidizing, so that makes the Cl2 here the oxidizing agent. Now, if it were a compound like this, then in this case, if this is an oxidation reduction reaction, then that means that this is both the oxidizing agent and the reducing agent, because there's only one compound on here, because this is what type of reaction? If you said decomposition, good job. But it's the whole compound that is the agent. It's only the single element that we're talking about that is either oxidized or reduced, though. So keep that in mind. If there is no change from one side to the other, then that means that it is not an oxidation reduction reaction. You would put Na on the line here. So circle the oxidizing agent and underline, this should say underline the reducing agent. I did not do that. I circled both and then wrote out to the side, but you're more than welcome to do it in that fashion. Doesn't matter as long as you got them separated, or you understand what's going on here. If this is actually oxidation reduction, you would circle it and underline it. But keep in mind, when you have soapy water, right? The soapy water cleans the dishes, so it's the cleaning agent. The dishes dirty up the water, right? So the dishes become clean because of the soapy water being the cleaning agent. The soapy water becomes dirty because the dirty dishes dirtied up the soapy water. So if this is oxidized, it is the reducing agent, and if this is reduced, it is the oxidizing agent. So there you go. I think what we can do is for 9 and 10 for the actual assignment. I will write the answers for the other ones and post those up so that you can see the answers and use those as practice. But this 9 and 10, well, for me it's page 9 and 10. Some of you guys are having issues with that. It will be these two. And then next week we will spend all that time on electrochemical cells and how batteries basically force electrons to flow in a direction, and then we can use that flow of electrons as electricity. Thank you. Hope you guys are doing well.